Hello. I'm giving everything a little bit of a second in order to kind of get Facebook up and going. Facebook Live always takes like a second to do. So let me pull up my Restream chat, and there we go. We are now live on Facebook as well. So hopefully you all are able to check this out and see it. I'm trying to pull up Restream chat right now so I can see everybody talking to me. Let me double check and make sure we're live on Periscope. So I'm going to see how we're going with that. Yes, we're live there. Okay, so we're live on Periscope, we're live on Facebook. Hopefully we're live on YouTube as well. I was having an issue before with YouTube because I actually had it turned on to two of the same channel, so it's actually streamed twice on YouTube, which is kind of funny. So now I have like duplicates of videos that I've done for the past two shows on YouTube, which is kind of crazy, but that's okay. So I can't see your comments yet. I'm still waiting for Restream chat to pop up. So once it does, I'll be able to catch up with all of your comments. And so this episode, since I just got the news yesterday, a paper that I'm a co-author on for cancer testing. It's a breast cancer test that we were looking at and developed involving exosomes and nanoparticle technology. That particular paper it's been accepted for publication, so I thought I'd share a little bit of that process and what you go through in regards to publication process, the types of papers, peer review, and that sort of thing. So I'm going to give people a second to pop on and see what's up. Thank you. I'm so excited. It's quite an amazing thing because it's a project that I worked on for about a year and a half. So it looks like it's up everywhere. Yay! Let me double check on YouTube. Hopefully it's up on YouTube. So it's a project that I was working on for about a year and a half in graduate school. Ah, it's up. All right, sweet. So if you want to talk to me, you can talk to me on Periscope as well as YouTube. I have a chat window for that. Facebook, I'll have to catch up with you a bit later if you're watching on Facebook, and I'll answer your questions in text afterwards. Okay, so publication and peer review. I did do a shorts version for peer review, but I didn't get into a whole lot of detail. I kind of got into the rigorous aspect of peer review, but today I'm going to talk about publication process, peer review, impact factor. What does that mean? What are the types of papers, research versus review? Because we hear, oh, it's a science paper, but people don't understand that there's different types. So we're going to talk about that too. So thank you for the congrats. I'll talk a little bit about my paper too as well, because that's exciting stuff. So let's go ahead and get started. That's my really cool intro that's done for me by a man gonna go for it. He hosts Mind the Gap on YouTube. He makes me all my cool intros and stuff. So if you like that, give a little shout out to him. So today, publication and peer review. What the heck is it? What is it? Why do we care? Why is peer review a thing? what does it feel like to go through that? I'll tell you a little bit, and all the things that are associated with publications. Okay, so peer review is a process. It's something that scientists rely heavily on in order to ensure that they do indeed come to these very specific conclusions associated with their data. And how they do that is they go through this peer review process. Now, in academia, as well as industry, it's important to get publications to where people can read within the scientific community, kind of scrutinize it, pick it apart, and be able to kind of repeat these types of results. Peer review. Reviewer number 2, making scientists cry and scream. Okay, yes, this is true. And I'll also talk about the different types of publications, review papers versus research papers. And I'm also going to talk about something that's getting increasingly more controversial in regards to impact factor. Thank you for the congrats. Oh, well, the peer review, it's already been through that. So I'm either 3rd or 4th author on this because I worked on it for 1.5 years, but I ended up graduating and leaving that lab. And so somebody else kind of picked up and carried on with my work. But I laid a lot of the grassroots for this particular test. So I'll talk a little bit about my paper. I'll just knock that out right now. So I worked in nanotechnology, and the paper that this particular one is discussing is going to be in theranostics. Essentially, I worked in 3D printing technology. I worked with nanoparticles in conjunction with what we use as plasmon resonance aspects of nanoparticles. They were conjugated with antibodies, and we were working with fairly aggressive strains of breast cancer because they have a high expression of receptors on the outside of the cell. So we wanted to generate a test that would detect exosomes. They are much smaller than cancer cells, okay? So particularly, we looked for, there's specific strains of cancer, the highly aggressive ones release exosomes into the bloodstream. So if you were able to take a blood sample from a person, you may not necessarily find a cancer cell, but if you can find an exosome, it's a teeny tiny little package that cells release into the bloodstream. If you're able to catch a few of those, that's a highly sensitive test compared to the current gold standard. So we generated a test based on 3D printing technology, in addition to gold covered slides that we modified with a certain type of PEG. We attached antibodies to that. Well, not antibodies. What we did is we covered it with PEG, and then that would allow the exosomes to stick. And then we went through and blasted it with gold nanoparticles that were covered in antibodies that would associate with those exosomes for this particular cancer. And so I worked on the actual isolation of the wells with the 3D printing. So I had to develop, I engineered the piece, the actual hands-on piece. PEG is polyethylene glycol. It's commonly used a lot in biochemistry type of labs. You can coat things with it, and it allows it to be really sticky to cells, and like particularly in this case exosomes. DSPEG is extra sticky, so it can catch extra little exosomes, and it adheres it to our gold slide. Yeah. So it adheres these exosomes to the gold slide. Now the part that my main focus was on, even though I helped conjugate particles, I helped grow, worked in cell culture. I've got all of those skills, even worked with trying to detection through dark field microscopy as well as Raman spec. We worked on that. I worked mostly on generating the 3D printed piece that goes on the top of the gold slide that we modified, where there was isolation of samples to where you could run multiple patients at one time. So I was 3D printing a lot. I molded silicone in the lab in order to get isolation of the samples in the wells. And then I also worked with Ryan and Ali in trying to develop the individual slots we'd go through, and they ran the tests in association with the device that I generated. So, yay! It's going to be published in Theranostics. And then Vojta picked up where I left off when I left that lab and when I graduated. So Vojta's on it as well. Vojta, Ryan, Ali, and me. But we all work together in order to coordinate this particular test. And so it's really exciting. It's kind of funny because we got our initial peer review notes last summer. Last summer, we got our peer review notes. And these notes, it was like 3 different reviewers. It took 10 scrolls to get through all of those notes. I'm like, oh my God. So I had already graduated. I wasn't in that lab anymore. And I'm like, gosh, this is brutal. Are you certain it's this? We need more experiments here. We need this over here. We need you to go back and explain this. How do you know it's this and not this other thing? It's very rigorous. You cannot have a thin skin and be and undergo the peer review process, because, you know, if stuff makes you cry a lot, science is not your thing. So going through all of that. And so they've managed to spend from last summer all the way through until, I'm guessing, January, trying to satisfy all of those questions for peer review, because since I'm not in the lab anymore, I couldn't help them with that aspect. So yay to Ali and Ryan and Vojta. So there you go. But it takes a long time. Thoughts on trying to go for an IG now, though? I'm in industry now, so I'm in a completely different monster altogether. But I'm enjoying what I'm doing with my job. I work in protein recombination, which is a completely separate thing and entirely new given my background in breast cancer and stuff. Hello, hello. So since I'm in industry now and I work in protein recombination, essentially it's kind of different, but it's still kind of cool. What is this test measuring? It's looking for exosomes for specific types of aggressive strains of breast cancer, like SKBR3, MCF7. Those particular strains are highly aggressive and they release exosomes in the bloodstream. And this tries to detect that. So, peer review is rough. It is a rough process, and it is not for the weak of heart or the thin-skinned. So let's talk a bit about this peer review process. I did do a shorts on my website and on my YouTube channel. It's about a 4 or 5 minute video that talks a bit about peer review, but it's really fast. It's like a really quick boom, boom, boom about the process. So I'm going to get into a bit more detail with peer review, as well as types of publications and impact factor. All right, so essentially peer review is evaluation of scientific, academic, or professional work by others working in the same field. Hello, everyone. Hello. So I'm so glad you guys like this idea. So essentially, you'll take your work, your hard-earned work, and you'll be like, I spent 1.5 years on this. And you give it over to a journal. You know, you're like, I'm going to send it to this journal and you know, hope it gets through. And then experts in the field that have been in the field for a long period of time are going to go through and scrutinize every single aspect of that. So it doesn't matter what field you're in, whatever your field is, you're going to submit it to a journal, and then that journal is going to go through a very rigorous process of asking questions and double checking and saying, but is this really the thing, or is it this? Make your case. So oftentimes reviewers will sit there and say, I'm not convinced by your data. You need to do more experiments, which means you got to go back and redo. The problem arises when the reviewers don't understand your work. Well, that's why you want to make certain you're sending your paper to a highly specific journal. For instance, this paper was originally submitted to Nanoletters. Nanoletters is a paper, or is a journal associated with nanoparticles. Nanoletters, nanoparticles. And then a sister journal, they're like, well, we don't know if this is good for nanoletters. How about theranostics? And so that's kind of like a sister journal that covers the same type of thing. And if you agree to go to this other sister journal, you don't have to undergo additional peer review from different people. You just have to meet the requirements of this peer review group, and then they'll put you in the sister journal. Okay, so you want to make certain you're submitting to highly specified journals that would know what it is that you're talking about. So that's kind of important. So that's kind of what the basis of peer review is. You get ripped apart by people like, you're going to have to convince us that this is correct. And it's 3 reviewers. And like I said, when we submitted this first paper, we were trying to go for nanoletters. And then they went through, and it was like 10 scrolls to get through all through these emails. And I'm just like, holy moly, that was this summer. It's just now been accepted, and here we are at the end of February. So kudos to my former lab mates for stepping up and doing all the experiments they needed to do in order to get the reviewers satisfied. So much love to Allie, Ryan, and Vojta. All right, so let's talk about this peer review process. This particular process can be quite rigorous. So I'm going to go to the big monitor here and blow this picture up a bit. Here we go. So what happens, and this is from libguides.evergreen.edu. So here's kind of what the process is. You get your idea, your theory, your hypothesis, or whatever thing that is that you're working on. You do your research. And we're going to talk about different types of papers. So let's assume that this is a research paper. I am thinking about getting my PhD, and I'm not looking forward to this part. You have a Bachelor's of Science in Computer Engineering. Yeah. Well, computer engineering, you can probably do pretty well with that, actually. You can probably get, because it's such a forward-moving technology, a lot, you know, computational chemists have so many publications because you can get stuff done pretty rapidly. So I wouldn't be too worried. So what happens is you get your idea, your theory, your hypothesis. Let's assume that this is a research paper. So you've done all of your experimentation, all right? You've done all of your experimentation. You write your paper. You have your manuscript, okay? So you get this proposed article, and you're like, I've written this out. Here's my manuscript. And then I'm going to send it to my journal. So you send it to the journal editor. So you've done your research, you've written your paper. Now you're going to send it to your journal editor. And they're going to be like, all right, I'm going to go through and I'm going to send it to 3 different people. 3 experts in this field that are going to rip you apart and let you know whether or not your data stands up. Then there's 3 different options. They either are like, this is fantastic all on its own. I have no questions, which, by the way, never happens. This right here doesn't happen on the first try. There's no way that happens on the first try. If it does, then these peer reviewers missed something. They're going to go through and they're going to check for everything. What's likely to happen is this little purple option here, revise. Revise, 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 more experimentation. We need more substantial evidence than this. Go back and redo. But if it's just horrible, then they'll just outright reject it. Okay, so that's a soul killer right there. If they're like, this sucks so bad, we want nothing to do with you. That, you know, that's terrible. But more than likely, what happens is you have to revise. That's usually the case with this. All right, so this other thing. Now we're going to talk about the actual detailed portions of every single aspect of the peer review process. This is from elsevier.com. They own a lot of different journals. It reminds me of head office inspections. They have to find 3 things wrong, and boy, do they look hard to find anything. There's always room for improvement. That's the thing. If you think my paper is perfect as it is, I cannot make this better. Somebody else is going to look at it like, no, here's this here, here's this here. So you have to go in with the thought that I can always do better. There's always room for improvement. I cannot possibly know anything. Peer review is an extremely humbling process. So I'm going to go through this criteria. So let me make it a bit bigger again. I'm going to blow it up a bit bigger for you. Here we go. All right. So let's say you have this new cancer test. You're like, this is fantastic. We're going to do this. Now, the basic criteria, the first thing it does is it looks at your references. And it's like, did you reference everybody correctly? Nope. Is there any basic science issues? Do you not understand how things work? Yes or no? If you fail, like right out the gate, you know, they're going to return it and say, no, thank you. They're going to, or even reject it. Then you have your first screening chief editor. They'll read through it and they're like, okay, this seems pretty promising. Let's go ahead and give it to some reviewers. Okay, so it's accepted for peer review. So then reviewer 1 and reviewer 2 kind of go through and they're like, peer review, and they're like, yes, okay, this is great. All right. And then, or if they'll go like, you know, no, they'll go to like the 4th reviewer. Then there's a 3rd reviewer that just kind of goes through and looks at your English and your grammar. Did you use your and your correctly? There and there, that sort of thing. Did you have a dangling participle? This could probably be written better. Okay. And so peer review, they're like, we're not certain still. There might even be a 4th reviewer. All right. And then they'll send it back to the chief editor with all kinds of notes and stuff. And the chief editor will be like, here is your 9 billion page of revisions that you have to do in order for us to be accept you into this journal. Okay. After the author revises, sends it back. These people, then these reviewers are like, okay, did this author satisfy all of our questions? Oops, sorry. There we go. Did this author satisfy all of our questions? Yes or no? And they're like, fantastic. We've accepted it for publication. And then the editorial board meeting gets together and then they designate which issue it's going into. Then you're published and you're like, woohoo, I made it. So it's actually a very stringent process and you have to meet the expectations of the reviewers in order to get into a particular journal. Now, as I mentioned before, you could say, this is a Nature paper. I'm going to get this published in Nature. I'm going to get this published in JACS, Journal of American Chemistry Society. I'm going to get it published in this journal. I'm going to, you know, you can submit it to a journal and be like, this is totally Nature worthy. And they'll be like, yeah, no, we don't think this is quite Nature material, but here's a sister publication. And if you agree to this sister publication, you don't have to go through peer review again. Just meet the expectations of these reviewers, and then we'll toss you into this journal. So, as I said before, our paper was originally sent to Nanoletters. And they were like, yeah, we don't know if this is Nanoletters material, so we're going to say Theranostics. And they're like, there you go. That's the journal it's going to be in. So that's kind of what you have to consider when you're undergoing peer review. We got our notes back in this past summer, and it's just now to where they're satisfied with everything in the paper. So it's a pretty rigorous process. So let's talk about the types of reviewers. Okay, the types of peer review. A lot of people don't know that you can have various types. You can have 3, single blind, double blind, and open, okay? There's a lot of controversy, and you might have read a lot of articles associating and a lot of studies now that are coming out about bias in peer review. And I talk a lot about cognitive bias on this particular show because of the fact it affects everyone. It even affects peer reviewers. They found that people tend to favor male authors more than female authors. That's an ingrained bias, and it's hard to overcome that. And that's why we kind of need more studies. But one way you can kind of eliminate bias altogether is through double-blind peer review. Okay? Single blind is that the reviewers are anonymous. So you don't know who's reading your paper. You don't know who's giving you these notes. All right? But they know who you are. So let's say that this bias kind of kicks in with these people. And you're like, hey, okay. So let's say that there's a professor that hates you. And that professor is like, oh, it's that student or that particular, I don't like them. They're not supposed to be biased in that way. But scientists are human, and we know that there's sexism in science. I mean, that's a thing that exists. Women have been left off of papers in the past. I know somebody who recently that has happened to them. So that's a real thing. So there's still sexism there. So you got single blind, double blind, both reviewers and authors are anonymous. So they leave the names off and they just read the data. That's probably the safest way to eliminate a lot of that bias. Yeah, most journals don't even allow you to use initials of first, middle name to avoid gender bias. Yeah. And then open is everybody knows who everybody is. There's, that's kind of interesting. You know, what if, you know, Stephen Hawking or somebody gets back into research and sends out a paper, you know, do you want to be the person that says Stephen Hawking messed up? Or do you want to be the person that's trying to find something to debunk them and rip them apart? Because if you've ever been to a science conference and listened to a talk, some of the questions are pretty brutal. What reason situations might a person decline a sister journal? I really don't know. It's so incredibly difficult to get published in journals in general. Depending if you want a decent, respectable journal, it's such a rigorous process. You don't want to have to, if you send it to a journal, here's the thing, you don't want to send your paper to several different journals at the same time. So you kind of have to put all your eggs in one basket, because if you're sending your journal to several different, your paper to several different journals, you might have a few that kind of overlap and they'll be like, wait, hold on, they submitted this to over here. Why are we getting it for this one? So you can't really submit to multiple places. So you have to be careful in who you send your paper to, and that's kind of where we get into this impact factor. So you don't want to say no. If somebody's like, well, if you meet all of these comments, we'll publish you in this. You're kind of like, okay, that's fine. You just kind of have to take what you can. Yeah, and in regards to open, knocking down the big guy would give you quite an ego trip, but then still, that's a bit of bias to a degree, you know? Or what if they all know each other and you hate your reviewer and they hate you? You're going to end up going, okay, then that's going to open a whole can of worms, especially like, that reviewer is sexist, or that reviewer is racist, or that reviewer is ageist, you know, or they have conservatism bias, you know, they won't. So then you open up a whole can of worms in regards to questioning, you know, especially if you have people that have interpersonal relationships, and that's like a conflict of interest, you know. So that's why I would prefer always double blind, because it kind of eliminates a lot of that bias. To me, that's like the best way to go in my thoughts. If this will go to the next screen. Whoops, I clicked it twice. And let me go back one. All right. So in regards to peer review, I mentioned before, articles can be transferred to other journals. Yes, it seems pretty cutthroat in science. Big names carry lots of weight in peer reviews. They do. One of my former research mentors is considered an expert in receptors, in orphan receptors. And she's also huge in organic chemistry as well as computational chemistry. She taught me everything I know about computational chemistry. It's fantastic. She is on a lot of different review boards. And so she learned early on not to have a thin skin. She's just like, yeah, whatever. She tried to type something and she goes, gosh, you know, but she's pretty cool. So in regards to peer review, articles can be transferred. So you may not get into Nature. You might get into like a sister journal that Nature supports. There's a lot of heavy scrutiny. So essentially, they're going to pick you apart. They're going to rip you a new one. You need to be able to answer their questions with data, and you have to defend your data. Peer review isn't some kind of tiptoey process. It's heavily rigorous. So it's not for thin skins. You can spend a year and a half or 2 years on some work and people just be like, you know, I'm not really convinced. Go do some more experiments. And you're just like, oh, okay. And that aside, having been a scientist, a lot of what you do is 80% failure. You spend all of this time trying to find a process that works. And when it finally works, you're like, wow, it finally works. Boy, this makes so much sense. And then somebody's like, yeah, no, I'm not convinced. Go back and do some more. And you're like, okay, more 80% failure. Oh, wow, we got it to work and we can repeat it. Oh, great. Let's send the data to the reviewers. So it's not for thin skins, and it's heavily rigorous. Now, a lot of times, you know, pretty much funding, if you're in the private sector, like in academia, funding rides on publications, but also in industry. In industry, they do have research and development technology. Publication is important. So if you're able to publish your findings in a particular journal, it gives the industry or the company that you're with a bit of clout. And it allows other scientists to kind of go, okay, here's an industry scientist. They did this work and now we're looking at it and so industry, because of the fact that they have better funding. And if you're in a company and you're able to get published on a particular thing that you've been working on for the company, they're more likely to fund more of your research and keep you around. So funding does ride on publications a lot. Now, retractions. We all know the story of Andrew Wakefield. Retraction is lethal to your career. So if a journal, after undergoing rigorous peer review, you've managed to falsify data or you've managed to fool them and they have to retract, you're never going to be published again. You're never going to be published again. And falsifying data can mean jail time because of fraud. So if the government funds any particular project that you have based on a publication and you falsified that data, depending on how much money is, you're looking at a lot of jail time because it's fraud. They gave you money on the basis that you were able to add on to your research to better our society, and you lied. So now it's time for jail. Like the guy who falsified all the data with wine and health benefits. Oh gosh, in China, falsifying data can mean the death penalty. Really? Wow. Now, high quality journals are going to be very rigorous in their peer review. And you can kind of see that also with their impact factor and quality of articles that they publish. So we're going to talk a bit about that. All right, so kind of wrapping up peer review. It is vital for the scientific process. It holds scientists accountable to their data. They have to defend it and they have to prove that this is what happened. This is a thing that everybody that wanted to do this research and had the resources could do. Data is verified by experts in the field and it's rigorous. They run you through the gauntlet and make you jump through flaming hoops in order to defend your data and show that it is substantial and that your conclusions do match up. Yes, it's a matter of shaming China to falsify and make their science look bad. Wow. Okay, I'll have to read up more on that. So let's talk about the types of publications. Woohoo! There's two specific types of papers. I'm sure there might be other derivations of this, but I'm going to mostly talk about research papers versus review papers. So if you're talking to somebody on a YouTube channel and they're throwing a review paper at you or they're throwing a research paper at you and they don't know the difference between the two, you can educate them. Yes, that's happened to me recently. Somebody was throwing review papers at me and I'm like, where's the original research you're talking about? They're like, well, I read it in this review paper. I'm like, but where's the original research? And they didn't understand that I want to read the original research to kind of pick it apart myself. So, oh gosh, you think it was someone claiming to have cloned humans that got the death penalty. Wow, that's scary. So if you're talking to a person, if somebody's like, yeah, there was this research article that said this and this and this and this, but they're like, here it is in a review paper. I'm like, no, I want the original article. So I'm talking about Tommy. Oh goodness. Oh bless. Yeah, on the Geek Room. I was on the Geek Room earlier this week, and Tommy, yeah. Go check out the Geek Room and you can see that particular conversation that we had. Oh goodness. So in the difference between research versus review papers, okay, research papers are the original work. They're the original experiments that a particular group performed, okay? They actually analyze the data, you know, they go through and they generate conclusions. It is a research experiment paper, okay? Saying just specifically what they did. A review paper reads other people's work, okay? You're essentially going through, you're reading other people's work. You might be looking for an answer, you know, to a particular question. It could generate new questions. It explains current knowledge, you know, and it also can assess effectiveness. Like a PhD dissertation, to a degree, yes. Like a PhD dissertation would have all of your papers together that you managed to get published during your time, and you go through and you explain your own work, you know, and you use references to kind of back up your work, but you're not regurgitating somebody else's work. Does that make sense? That's different from review. Review is you're reading other people's work and regurgitating it for people. That's the difference. Kind of like what I do on science communication. I read other people's work and then I explain it. I'm a walking review paper, but I've also done original work. So, but for this intents and purposes with this project here, I'm a walking review paper. That's pretty much all of my little talks here. It's like a walking review paper discussing other people's work in an easily accessible tiny little package that you can take with you in your pocket. That's what that is. So that's kind of like an example. All right, so research. Research is based on the scientific method format. So when you go through a research paper, you're going to see the hypothesis. You know, what is the answer to the question? They're asking a question. What do they think the answer is? They're going to show you the hypothesis. They're going to talk about how they go about finding the answer to the, you know, making sure this is the answer to the question, you know. Then they're going to talk about the experiment, all the materials and methods and what they did. Then they're going to talk about their data, their results. Okay, this is the data that we got from the experiment. And then they're going to go, okay, let's analyze the data, which is what they do when they discuss the results. And then the conclusion will go through and it will talk about whether or not the results in the data match up and defend the hypothesis. So when you're looking at a research paper, it follows through the scientific method perfectly, step by step. And it should be a repeatable experiment. So that's research. That's original work content versus a review. Now let's talk about a review. Review papers can get a bit more, you know, taxing, all right? So, review paper, it basically summarizes concepts. So, if you wanted to find a review paper on the LPA2 receptor, I've read a lot of review papers on the LPA molecule, LPA2 receptor. I've read review papers on computational methods regarding the LPA2 receptor to kind of get an idea, but I didn't base any work I did on that. If I want to understand something a bit better, I can read a review paper, but I'm going to dig in and find the experiments they're talking about, and I'm going to scrutinize that. So So it can summarize concepts, which is quite useful for people that are trying to find a starting point for their own research, right? It summarizes previous work. So-and-so et al. Performed this experiment and they got these results. So-and-so et al. Performed this experiment and they got these results. These results collectively reinforce this particular idea, which is great, but if you got to be careful with review papers, because you got to go through and look at the experiments that they're referencing, the research that they're referencing. Double check, you know, sample size, that sort of thing. It's important to still scrutinize review papers. Meta-analysis is quite important because it can go through and look at trends within a particular topic. So autism and vaccines. Somebody performed a meta-analysis on millions of kids, went through, got the data. They showed how many kids, you know, this particular research project they did, worked with this many kids, this was their result. This particular research, they worked with this many kids, this is their result. And they found through meta-analysis with trends in various populations, no link to autism and vaccines based on research done with various populations. So you take other people's research that are based within a topic and you look for the trends, right? And that can be any particular variable. Review papers can also generate more questions and say, okay, so in this particular topic, we know all of this research has been done, and they all kind of get us back to this one little question here. Okay, pick a medical treatment. So they can go through and we know this medical treatment gives us this, but every single paper always says we need more research associated with this one topic. So this is a possible direction for research. After having read these 200 papers, we see that this is a current thing that we have to kind of tackle. Like with CRISPR, you can read everything about CRISPR and we still have a problem with dosage of this particular enzyme in people because it can actually cause DNA damage or hook up to the wrong part of the DNA. That's like a consensus throughout every single CRISPR paper. So we need more information and we need to understand better what this particular enzyme does in the long term. How long does it stay in the body? We need a large amount of it in order for it to work, and that could cause health problems. So review papers can kind of generate possible directions for research in order to answer a lot of the questions that people end up with after they perform all their experiments and get published. Now, we do see it's common in medical journals. Why? Because doctors need to keep up to date with a lot of the new research associated with their field. Cancer, you know, being one. STDs being another. Maybe, you know, pediatrics. What are the new things in pediatrics? Are there new vaccines that don't hurt little babies when you give them shots? You know, what is the latest trend? So review articles are quite useful, especially in medical journals, because it allows a one-stop shop for doctors to go and read what the latest information is, because, you know, they're probably short on time. And then they can go through and say, hey, wait, that study sounds interesting. Then that can be like, they can read that and get a bit more information about it. So we see a lot of review articles in medical journals for that reason, because it's just useful for doctors to be able to kind of read through and see what the updates are without having to read individual papers. Their time is limited, right? So we're kind of looking at that. So far we've talked about peer review and how soul-crushing it is. We've talked about the types of publications that you can have, the types of papers. And so I want to talk a little bit more about a review as far as review articles and what they tend to be. You know, it does, I've kind of tossed around the idea of, like, you know, possibly reading a review article. But you have to remember, it isn't original research. Now, review articles tend to be a few different types. You can have a narrative, like I said before, that's kind of regurgitating and explaining existing knowledge. You can have a systematic review looking for an answer to a question. And you can find it in existing literature. So if you want to find out, All right, what is the effectiveness of using scanning electron microscopy with this particular thing? Is the sample reusable or not? Or are there any new measures in scanning electron microscopy and fluorescence? Are there any new things associated with that? What is the, so you can go through and find a systematic review. And then I talked about meta-analysis. And so review papers are good resources, but it is important to consider the original research it references by looking at the studies, the methods, sample size, conflicts of interest. So you still have to scrutinize review papers and make certain that what they're referencing is substantial. So review papers should not be exempt from this scrutiny just because they're explaining other people's research. Checking the journal that a review paper is published in can help weed out potentially misleading review papers. How much space is there for posting new directions at the end of a review paper? Well, I mean, it really just depends on how long your review paper is. Some review papers are really long. Some are really short. It just depends on what it is that you're talking about. And if you're doing a review paper on relatively new technology that's just come out, you're not going to have a lot of references. Some review papers could be like categorically going through what we used to think was accurate and all the new information that's come out that's kind of changed the direction. So you can have a review paper like that. Oh, wow. Someone gave you a review paper to look at, had 108 sources. Yeah, that's not entirely uncommon. It depends on, like I said, how much, what all they're covering. So it's actually more difficult to review a review paper than a standalone one. Yeah, it kind of is, because again, you have to go through and you have to make certain that they're referencing decent research, good research, and not hack research or, can you imagine a review paper? I should do this just for fun. And I might do this just for my own enjoyment. A review paper of Deepak Chopra studies. Reviewing a review paper sounds awful. I should do a review paper of Deepak Chopra studies. Just an open review paper. And just take like 15 of his studies or something that is published, or whatever. And just write up everything. And just rip it apart. Man, it would be comical. That would be fun for me to systematically rip apart 10 of Deepak Chopra's papers. In this paper, blah, 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 blah. And then in this paper, blah, 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 blah. Look at this. The sample size is 2. And just really just for comedy. And probably just have to do it for comical purposes. Somebody be like, wow, but it would be very thorough. Let me find the time to do that, right? Deepak Chopra undergoes scientist male peer review and wakes up, completely destroyed. He's now a pile of rubble. But I'm sure he doesn't care. He probably would not care what I think. He doesn't care what the whole of the scientific community thinks anyway. So, what are you going to do? All right. So, impact factor. Now, in my peer review shorts, my shorter video of this, you would have to go through all 108 sources. There's a key for that in kind of determining a little bit whether or not something's substantial. An impact factor can help you with that in regards to the journal that these sources are published. Okay. Impact factor is a measure that reflects how often a paper within a particular journal would be cited. Okay. Unless the first 10 were bunk. Yeah. If you look at where a paper is being published, some people are like, this is a peer-reviewed article, and they send it to me and it's like a homeopathy journal. I'm like, really? Really? Yeah, that's Yeah, I don't think so. If you send me something from a homeopathy journal, I am not going to consider it peer reviewed because it's a homeopathy journal. So yeah, no. Stuff like that. The idea their peer review is different for different journals, and some just let things through. And so anything that's considered well established is going to have a decent amount of citations. All right. A scientist ripped apart Gwyneth Paltrow's pseudoscience is great. And I do that. I actually talk about that in my pseudoscience video. I was quoted in the Washington Post. Sorry, my Twitter was talking to Gwyneth Paltrow. That was my 5 minutes of fame in the Washington Post, which is kind of fun. They reference me a little bit, and I'm just like, that was a nice day to wake up to, you know, but that's all right. So what is the impact factor? Academics and grant givers kind of rely on articles being published in high impact journals in order to get or give funding. So what is the math on this? A equals the number of times articles were published between, let's say, 2015 and 2016 that were cited in 2017. Okay, so that's A, the number of times an article was published. All right. B is the total number of citable items published in 2015 and 2016. And so citable items being like, is this new? You know, is this new stuff, you know, that is published, or the citable items associated with that, and how many times there were actual publications from that journal that were cited. And so you divide A by B and you get your impact factor. All right. So I've got, let me get to it. I'm going to show you. This is, and I pull this off of jcr.insights.thomasrouters.com. They're in charge of the impact factor. All right. So here are the top 10 journals with their impact factors listed. The number one top 10 journal with the highest impact factor, IF, that's the little red here. This is the highest impact factor. That's the Cancer Journal for Clinicians. All right. Now notice it doesn't have a whole lot of citations, but it has a giant impact factor. Doesn't have as much in reference to that, but that has to do with the math. So that means they have fewer citable items in comparison to their total sites. So, and these are based on thousands here. So this is times 1,000. Otherwise, my graph would have looked really weird. All right. So the New England Journal of Medicine, they have a lot of citations, but their impact factor isn't as much as here. And that's largely due to the fact that they have probably a lot of citable items, but they also have a lot of citations. Now look at Nature. This is how many total citations. We're talking like 650,000 citations, but their impact factor might be 40. So you have to go, okay. This is, it can kind of be weird to get your brain around this kind of math. So even though they only have 40, let's see, let's do the math on that. We got what, 650,000. That's what the impact factor is. We know that's A divided by B, right? You guys got your calculators out? You got your calculators out? So that's 40, 65, it's like 650,000. Times 40. So we've got a substantial amount here of citable items that kind of counters all of this here. So you have a huge number here that counters all of this here. So let's look at these numbers. Here's the table. There we go. So even though Nature, okay, has 671,000 That's how many citations there were. Their impact factor is only this. So 671,000 divided by 40. So they had 16,775 citable items. All right, now let's look at this. This is the highest one. This is Cancer Journal for Clinicians. All right, they had 25,000 citations. That's not as much as Nature now, is it? 187.04. That means they had 133, just 133 citable items. So because they had such a huge amount of citable items in comparison to, you know, with this particular fraction, the numbers come out that the impact factor says you're going to be cited 187 times if you're in the Cancer Journal for Clinicians. So it's just like, you know, these numbers matter. If I had to pick between Cancer Journal for Clinicians or Nature, I would much rather be in Nature, even though they're like, you're only going to be published 40 times. Oh my gosh, they had 671,000 citations. So you kind of have to sit there and go, all right, impact factor numbers sometimes need to be taken with a grain of salt. You know what I mean? Because of the fact that Thomas Reuters, that particular company, they look at what's the citable items. You know, it's kind of vague on what they think the citable items are. And there's a lot of scrutiny in regards to impact factors and how they're calculated. So how do they get these citable items? You know, it's a bit opaque. They're a bit opaque in their calculations, and they're not 100% clear. So you watched my debate with Tommy. That was an interesting debate. So on the Geek Room. All right. So impact factor, it's a measure reflecting how often an article from a particular journal gets cited. So we looked at the Cancer for Clinicians. Its impact factor is 187. That means your article is going to get cited 187 times. But truthfully, you know, I really didn't even know about Cancer for Clinicians, but I knew about Nature. You hear more about Nature than you do that. So even it's kind of weird. Nature, you might get 40 citations, but Nature, we all know, is more prestigious. It's been around a lot longer. So impact factor doesn't always kind of play a role. Cited items, new items learned affect the score. So it's going to affect your score for these new items that were learned, or what they consider citable items. The number of citations affects the score. If you publish in a prestigious journal, you're going to get cited. That's kind of what they go with impact factor. If you publish in this journal, you're going to get cited. But the numbers, we know, can be misleading. And we know that because we can look and say, just because you're published in a prestigious journal doesn't necessarily mean you're going to be cited. That's the one thing. And the other thing is that the citable items, and the way that they go through and find out how often a particular group is cited, or a particular journal is cited, is kind of opaque as well. So there's an article about this in Science Mag that kind of addresses this, Science Magazine, sciencemag.com. Just because you publish in a high impact factor journal does not mean you will get cited. The calculations from the JIF, Journal Impact Factor, is a bit opaque. And largely, a lot of the citation distributions are so skewed that up to 75% of the articles in any given journal have lower citation counts than the journal's average number. So the average number could be a lot higher than, you know, what the actual citation counts are. So trying to use just the impact factor to forecast the impact of any particular paper is kind of really guesswork. So I did bring up funding and publishing. Oh, yes. The after show, I did sing. I sang Michael Jackson on the Geek Room. Citation should be how useful your work is to others. Yes, that's true as well. You've reviewed funding proposals and try to look at number of publications to grad date, early career. Yeah, that's cool. And they get shafted. Any suggestions when looking at impact factor? when you're looking at impact factor, if you know any kind of which journals are actually prestigious as opposed to high impact factors, like that journal for cancer for clinicians, I only just learned about that about 20 minutes ago, or no, about like what, 8:30, like an hour or so ago. I actually pulled up, and I can let me pull this up for you. There's a website you can go to and pull up the actual impact factors, and here you go. Here's the spreadsheet that I used to make that chart. So I'm going to pull this up. Look, this might take me a second. Here's all the journals that participate in the journal citation reports. And this is the raw data, so you know I'm not making this up. This is the raw data you can download. And the thing is journal citation reports, they do release these after a while. This is from 2017. And you can find them usually pretty readily on the internet. Somebody, downloaded it. But the thing is you have to pay to be part of it, and then they have more analysis. Time is the best judge. So it's a good idea to kind of look at the trends over a period of time. Not necessarily right then, but like I said, I've never heard of the Cancer Journal for Clinicians until like this morning. I've heard of the New England Journal of Medicine. Of course, I've heard of Nature. There's Nature Biotech, Nature Reviews Genetics, Nature Reviews Molecular Cell Biology, Nature Reviews Drug Discovery. These are all sister journals of Nature. And so if you know your prestigious journals and you have something associated with that, that's pretty good. Now, what you want to avoid altogether, I'm going to go to the bottom here. All right. We got a lot of not availables. So we have like the Journal of Veterinary Research. We don't know about that at all. We have impact factors that are less than 1. I would avoid that. Electronics World, 0.026, Food Australia. Nobody reads these. So you need to at least get up here. Let's see. Let's find the journal that my paper is going to be published in. It's a lot further up than this. Now it's, keep in mind there's like, over 12,000 journals in this list. 12,000 journals. We're going to move up to where mine is. Mine's going to be. We're still going up, up. Hold on. Yep, we're close. Where is it? It's in the 200. All right, so mine is right here. This little sweet spot right here. All right. So theranostics. That will be where my paper is going, that I'm a co-author on, is going to be published. Yes, you may follow certain journals due to your field, and that's true. So if it's associated with your field, those are the ones you kind of want to go with. Like Nature's great, but you want, if you're in genetics, Nature Genetics, or things associated with that. Here's theranostics, nanoletters. So my particular field, I would be looking at that and what the sister journals are, and are those reputable? What is their peer review process? The peer review process to me is more substantial than, and you kind of see that with the amount of citations. So not necessarily what the impact factor is. I'd look more towards the citations, and also if it's relative to your field, and kind of look to see what those journals are, and usually they'll tell you what their peer review process is. So if it's rigorous, then it's going to be good work. That's kind of how I would get around the impact factor thing. But yeah, there's mine, 8.712. We're not in the 187 of the Cancer for Clinicians, but hey, still it's pretty reasonable. It's all right. Ain't gonna hate on that. I'll take what I can get. So that's not too bad. So if we go back to that, all right, so you get more cred the more prestigious the journal is in, but that's going to go with a lot of the peer review process. Who sits on what boards, and is it relevant to your field? That's important. And there's heavy criticism. So we got to kind of keep that in mind when we're dealing with impact factor. I would say take that in consideration, but also look at their peer review process. Our old joke was that 8.72 includes the 8 people in our lab. Maybe 3/4 is like maybe a grad student that's helping out. That's the 3/4, you know. So peer review, it's necessary, and it's a very rigorous process, and it can be soul crushing, especially if you're going through and you're just like, eh. But graduate school, if you're familiar with graduate school, every time you go in front of your committee, they're just ripping you apart, not because they're mean, but to help prepare you for that process. Publications, you have research papers and you have review papers. They're 2 entirely different things. Review papers are good bouncing points to kind of understand a concept, but it's important to get to the research, the meat of it, and critique it and scrutinize it and get through it and make certain it's not bad science. Now, the type of journal that the review paper is published in, if it's more prestigious and they have a good solid peer review process, then you know, you can kind of tell. All right, they're going through and checking their references. As we saw, that's the first thing they do, basic science, and check your references. You know, if it gets thrown out, you know, they're just like, no, we're not doing this. And then impact factor is kind of associated with journal prestige and article citations. So, but a lot of people are saying you should probably take that with a grain of salt, because the way that stuff is reported, it's kind of opaque, and it's more like a little bit of a guideline, but the numbers are skewed, and it's, you know, trends over time, and learning about a journal and its history with retractions. That's important. Its history of publishing fraudulent data. That's another thing. Its peer review process. Yes. And, you know, is it relevant in your field? What is the most cited paper in science? Oh my gosh, I have no idea. That's a really good question. So I give you guys homework. What do you guys think is the most cited paper in science? And hit me up on Twitter with what you find. And maybe we can have like an open discussion there. What is the most cited paper in science? It depends on, I guess, your field. You know, which field are you talking about? Is the Lowry protein assay. You think that's what it is? Well, that's cool. Well, send that to me and let's have a look. So if you have any questions ever, you can find me pretty much everywhere. But and I'm going to show you where you can find me. I'm going to take a moment to thank my patrons. I've got new patrons. Yay! Thank you for contributing. You're important to me, and I'm working on getting new stuff for you guys. So if you're some of the higher paying patrons that just joined, you get to pick an artistic print or a signed poster or whatever, you know, one of those things. I'll ship it to you. And so and I have like artists that I associate with that draw like really neat artwork that's kind of associated with the various sciences. And so you have access to that. You also get access to my podcast a week in advance before the general population. You can go on patreon.com/scientistmel, and I've started implementing new video streams that I can stream from my phone just for those individuals. So you got to see some stuff from Neil deGrasse Tyson on there just for you guys. So stuff like that, and you help make what I do possible just by keeping the lights on. And so because of that, I'm able to just stream to lots of different places now, including Facebook. So we have Facebook people watching us. I have a website. You can find me at sciencistmail.com. I write articles. I generate teacher resources. There's all kinds of stuff there for you. My podcast is hosted there. You can find it on iTunes as well. Patreon, Periscope. Some of you are watching on Periscope. I'm on YouTube and Facebook. My guess is it wouldn't be along the lines of megastructures around a planet or Pluto being demoted. Don't forget to turn the lights off when you leave. So hit me up, and if you have questions or anything, you know, just let me know. I do appearances on other shows, including the Geek Room, the Great Debate Community, Mind the Gap. I've shown up on Jackson Wheat's channel, and so I'm hopping around a lot, trying to kind of boost scientific literacy and kind of connect us all together. So if you want me to be on your show, I'm happy to do that too. I do travel and do talks as well. So If you want me to come out and talk to your kids in the classroom or at the university or somewhere else, or just do a chat, you know, I'm happy to do that, stream live there. That's kind of when some of my goals are. When I get towards boosting more sponsorship, I'll be able to travel and interact with people and do shows on site where we can enjoy science together, and it'd be cool. Maybe someday I can talk like Neil deGrasse Tyson. And I'm currently writing my cognitive bias book. And if you're a patron, you'll be able to have access to that before other people when I finish the cognitive bias book. Make it up to New England. I might. I'll be happy to come up there. I'll be happy to come up there. Anti-crepuscular rays explained. Yes. I have a list. I've made a list. You know, from last time. I still got my list here from people. I do keep lists, active lists of stuff that people want to talk about. And so it's awesome. My cognitive bias book. All right, the cognitive bias book I'm writing right now talks about the different cognitive biases that affect our regular decision making, and how to, in real world examples of how biases kick in the moment. All right. And how they can overlap. And I also talk about societal cognitive bias that we see, especially with the current environment. We have a lot of cognitive biases that are going unchecked. Some bias is healthy and good for you, but if it goes unchecked, that's where we run into a lot of problems. And so my book will talk about all the different cognitive biases, what research says about cognitive bias, how they overlap, real world and real life applications in your own personal life, in addition to holistically how your cognitive bias not only hurts other people sometimes, but it can hurt yourself and put you in toxic situations and kind of keep you there. So and how it can kind of stint our growth, not only as individuals but as society, as well as tools as to determining what your biases are, what your cognitive biases are. So you have to kind of it's like active work to keep them in check. And scientists really have to do that, and instruments and peer review allow us a space to where we might have a bias going on that we don't realize. Other people can go like, okay, hold on. That's confirmation bias, friend. You know, we're going to have to do better than this. You know, availability heuristic, pro-innovation bias, that's another thing. So peer review kind of eliminates a lot of those biases. So I touch a little bit on how bias is addressed in the scientific community and how you can kind of use those skills in your daily life. So that's what my book's about. I hope that was a good explanation. I've got the chapters out and I'm outlining them now. I'm writing the preface as we speak. So hopefully you'll enjoy that. And I'll kind of make it fun and a little bit tongue-in-cheek and kind of bouncy and upbeat. But we will dig down into what makes us screw ourselves up a little bit. But that's okay. So thank you for watching this episode of the Science of Publication and Peer Review. You can find me on Twitter, patreon.com, scientistmail.com. My patronage starts at $1 a month. If you like what I do and want to buy me a coffee, $1 a month, man. Follow my Twitter followers, gave me $1 a month. I could quit my industry job and do this full time. So this would be my full-time job, and I would travel out to various cities and I would come out and talk to you in your classrooms and everywhere. So wherever you'd want me to be. Thank you for hopping on here. I'm so glad that this has been informative, and I'm always available for your questions. I hope you guys have a fantastic Saturday. Awesome. I'm so glad you enjoyed Science Saturday morning. And I will be back next Saturday, and I'm starting a new show, Spirited Science. And if you want to be on my show, if you're a scientist, a science enthusiast, or an educator, I'm looking for people to share an adult beverage with on a video live stream and talk about a particular topic of science. So it might be like Darwin and whiskey. So we will talk, every person will talk about Darwin and have a glass of whiskey. But they'll each have an aspect of that particular topic that they'll bring to the discussion. You know, so we might be like, you know, space and vodka, you know, or geolocation and cider. I don't know. Usually they'll have some kind of link together. I'm still writing them, but there you go. If you want to be a part of that, message me and we'll have a talk. Thank you so much for being here. I hope you guys have a fantastic Saturday, and I will see you really, really soon. Space and Russia vodka. There you go. Sputnik and vodka. That's an episode right there, isn't it? Talk about Sputnik and vodka, having a vodka beverage. Spirited Science. Look for it on my YouTube channel. You guys have a fantastic Saturday, and I will see you guys around soon. And listen for my podcast. A new episode is coming out Sunday for my patrons. Woohoo! It'll be with PZ Myers.